Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Addition la probability for mutually exclusive events. Addition law of probability for mutually exclusive events. That is, we have to prove that probability of A union B must be equal to probability of A plus probability of B, where A and B are mutually exclusive. To prove this theorem, we know that if A and B are mutually exclusive, are not mutually exclusive, are not mutually exclusive, then probability of A union B will be equal to probability of A plus probability of B minus probability of A intersection B. We know that if A and B are mutually exclusive, then probability of A intersection B will be equal to probability of pi, which is equal to 0. Is for mutually exclusive event, the intersection area is always equal to a null set, and probability of null set or impossible set, empty set, null set. This is null set, empty set, empty set, or in other word, it is impossible event. In other word, it is impossible event. So, since A and B are mutually exclusive, since A and B are mutually exclusive given in the statement, so A intersection B is empty set and probability of A intersection B is equal to probability of pi, probability of impossible event, and it is 0. Put this in equation number A, put I in double I in A, so A implies probability of A union B will be equal to probability of A plus probability of B minus 0, implies that probability of A union B will be equal to probability of A plus probability of B. Hence, it proved. For n is greater than or equal to 2 and mutually exclusive events, n is equal for n is greater than or equal to 2 events, that is for A1, A2 up to AN, where AIs for I equal to 1, 2 up to N are mutually exclusive. Probability of A1 union A2 union up to union AN will be equal to probability of union I runs from 1 to N of AI will be equal to summation I runs from 1 to N probability of AI. So, to prove this theorem, we used mathematical induction. Mathematical induction. What is mathematical induction? In first step, we will show that the result is true for n equal to 2. And second step, we suppose that it is true for n equal to k. In third step, we have to prove that the theorem is true. We have to prove that the theorem is true for n equal to k plus 1. So first we check the results. For n equal to 2, for n equal to 2, that is I runs from 1 to 2, that is we have two events A1 and A2. Therefore, probability of A1 union A2 is equal to probability of A1 plus probability of A2. For A1 and A2 to be mutually exclusive. Let the result is true for n equal to k. Let the result is true for n equal to k. Therefore, probability of A1 union A2 union up to so on union AK will be equal to probability of A1 plus probability of A2 plus up to so on plus probability of AK. This will be equal to summation I runs from 1 to k probability of AI. Now we have to prove the result for n equal to, now we come to a third step that we have to prove the result for n equal to k plus 1. For this, we consider two events, that is probability of Union I runs from 1 to k of AI. Union ak plus 1. So we consider these two events, that is one event is this one and second event is this one. So these are the two events. So we know that for these two events, this must be equal to probability of union I runs from 1 to k of AI plus probability of ak plus 1. And this can be written as expand this union. We expand this union, that is a1 union a2 union up to so on up to ak plus probability of ak plus 1. ये अपनी जगह हम लिखते हैं. We have written this in its own place. Now we know by this equation, that is probability of a1 union a2 union ak, this is equal to this thing. So this is, suppose this is equation number 1. So therefore probability of, अगर हम इसको कंबाइन करते हैं, इसको हम कंबाइन करते हैं तो ये आपके साथ आता है यूनियन आई रन्स फ्रॉम 1 to k plus 1 ai. This is equal to, and we know by equation number 1, this is equal to I runs from 1 to k probability of ai. So this can be written as I runs from 1 to k probability of ai plus probability of ak plus 1. So when we sum this, so you can extend the sum from I runs from 1 to k to I runs from 1 to k plus 1. So we extend this sum from 1 to k plus 1, and we can write probability of ai. Implies that probability of union I runs from 1 to k plus 1 of ai is equal to summation I runs from 1 to k plus 1 probability of ai, which is the required result.